Right, I guess it's about time to go ahead and get started. Um, my name is Rick LeShane. Today we're going to talk about uh, pure air filtration and the benefits of the V-Bank transition, high flow applications, our VTS odor control system. Again, my name is Rick LeShane. I'm the Territorial Sales Manager for PureAir. I guess I'll tell you a little bit about myself. I have been in the water and wastewater world for probably, well, definitely 30 plus years. And I have been with Pure Air Filtration for about the past 7 years. And again, today we're going to talk a little bit about our high flow, very efficient V-Bank transition system, otherwise known as a VTS odor control system. Go ahead and get started here. Table of contents we're going to talk about today. Talk, of course, about gas phase filtration, a little bit of Chemazorb media, of course, the V-Bank system, a little overview of it, benefits, maintenance, again, which is a great benefit of this piece of equipment, configurations, some case studies, see what some other folks have to say about our stuff, and some design features. Introduction to pure air filtration, manufacturing facility outside of the city of Atlanta, Georgia, approximately 45, probably closer to 50 employees right now. Sales to more than 45 countries. We are ISO certified. Some of our more notable customers, of course, throwing a bunch for Georgia or one for Georgia right away because we're in Georgia, but Fulton County, Georgia, Orange County, California, Orange County, Florida, City of Austin. Some of industrial users, in Kalamazoo and California by Bioenergy. But again, just some of the notable customers that we have worked with over the years. Talk a little bit about what sets Pure Air apart. Municipal applications, and we're not just odor control. We'll talk about that a little bit. What we're mainly talking about there is, and we'll get into it a little more. But we do odor control, and we do a few other things also associated with corrosion and emergency gas scrubbers. Custom solutions. Again, you can go from a very low flow situation, low capital costs, to some very, very high customizable systems, which we'll talk a little bit about today in the VTS unit. Multiple families of specialty absorbents. Again, we do provide, you can have, your basic coconut and coal activated carbons, along with many engineered carbons. The conditioning of the air, talk about that throughout the presentation. Very important to eliminate, but take the majority of the moisture and the humidity, out of the airflow. Really does help the longevity of the media. And then the monitoring of the absorbent consumption. Another important thing to monitor the consumption, so you know when breakthrough of odors are going to happen, and it gives you chances to plan to replace the media when needed. Again, multiple applications. And so again, odor control, high efficiency complete odor control, removal systems. We have multiple configurations. Today, we're mainly going to talk about the VTS. But again, just like talking about emergency gas scrubbers, something that we also do. Low maintenance. Again, it uses a dry engineered media that actually turns into a harmless salt compound. It's because it is a chemical reaction when it comes in contact with the chlorine. And again, very important to have around to protect the surrounding population near the plant, whether it be a water plant or a wastewater treatment plant, and the employees of those plants. Protecting electronics, Pure Air. Yes, we do odor control. So, a lot of people think of H2S. Yes, it has a bad odor to it, but it's also very corrosive. So that's something else we do. We won't talk about that too much today, but again, that's how we treat H2S concerning the corrosiveness of it. Indoor air quality, improve indoor air. A good example of that is, say, at an airport, where you don't want to be sitting there waiting on your plane, smelling airplane jet fuel. And so basically, we will put systems at the intake of the HVAC systems, and it will take the offensive odors and smells out so that the people inside the facility don't smell it. Say, again, in this example, jet fuel. And then we've also gotten into the biogas, and it's also referred to as sour gas situation. Again, at a wastewater plant where you have a digester, which can have very high H2S concentrations, and we have some medias that can handle that. As far as gas phase technology, this is in the gas phase, it's in the air, it's not a liquid phase where it's not in the drinking water and you're trying to filter out certain things. This is, gas phase. And again, removing molecules of gas from the air is what we're talking about. Here's some of the more common gases: your hydrogen sulfide, your sulfur dioxide, chlorine, ammonia, and other VOCs. This is an example of a media bed, and the media expires in zones. You kind of see here's where the contaminated air is coming in. Again, just envision this is the media inside one of the vessels. You can see you've got a spent area, you've got an active transfer zone, and this is where it's either the absorption or the chemical reaction. The chemosorb is taking place and handling and eliminating the odors. And then you have your unused portions. Again, it just kind of gives you a little diagram of what's going on inside that media bed. Again, many different type of engineered medias, along with your like PureAir ACX, that's our coal-based activated carbon. And here's the ACC, which is the coconut. But again, these are some engineered carbons where we use alumina spheres treated with potassium permanganate, whether it be in its pure form or mixed with blended with another type of media. This is normally what we're going to use in what we refer to as a polishing layer that gets rid of all the odors associated with wastewater, other than the H2S. So what those are mainly used for. But again, you can see that we just have an array of different type of engineered medias for different situations. This is kind of a quick visual of this is some carbon, and you can see again very porous. What happens here is that the odors or the odor molecules literally get absorbed or stuck into these pores. Okay, and this is actually an example of more of a chemsorb situation where this is, like, say, an aluminum sphere, very porous, treated with a chemical. There's a chemical reaction that happens when the odorous molecules go into those pores. A little bit about carbon versus, pure engineered absorbents. Activated carbon it's not UL approved. Treats humidity, water as a contaminant. Basically what they're saying there, so those pores can get filled with the humidity or the water and leave less room for the actual odor molecules to be absorbed. It is a reversible process. If you get a high temperature for any reason or a high spike in H2S, which a lot of times is caused by high oxygen, the molecules can be pushed out. And then you end up with odor breakthrough, and that's not what you're trying to. It's not the end result that you want with odor control. So that can happen with your regular activated carbons. Let's see, it can be hazardous waste when spent. A little harder to get to a landfill. it can catch on fire. It has caught on fire, and extremely difficult to determine media life. Basically, say at a lab, something that we do here at PureAir with no cost to the customer, but send in samples, and it can be harder to test and see what kind of results with just regular activated carbons. The advantages of engineered absorbed medias. It is UL certified. System is designed for a broader amount of contaminants. Again, you can see the all the different types of media we have for all the different types of the gases. It can be associated with wastewater and other industries. It is a irreversible process, and again, it's a chemical reaction. So it chemically treats and changes the chemistry of the odor molecule, either absorbs it or changes it. Again, I think I had talked about earlier with our safety Zorb. When it comes in contact with chlorine in our immersion gas scrubbers, it turns the gas into a harmless compound, salt compound. It's very landfillable and non-hazardous. It will not promote bacteria or fungal growth, especially as they say with the potassium permanganate. Again, is a good fungicide, and again, so it will not promote the growth of bacteria. High capacity rates, again, with and we'll go over that a little more with something the chart that I'm going to bring up next, but much more as far as capacity per weight with the engineered medias. Again, the lab tests are accurate, and you can measure more accurately as far as the consumption and what's left or how much of the media has expired, and some of the tests that we do here in our lab. Yeah, this is the chart I was talking about, and it goes from everything from your coal-based carbon, which is your basic activated carbon, which is RACX. Got your coconut shell carbons, and you can see that of course the porosities, how porous is it? Capture VOCs, reduce sulfur compounds, H2S. How does it handle water? And then it gets the cost per pound and the cost to actually use it when it comes to absorbing the H2S. But you can see here where the activated carbon in the coconut activated carbon, great as far as being very porous. Okay, VOC, very good, very excellent. These things are great for VOC capture, but you can see where you get into some of these other things that are associated with actually like a wastewater plant, you don't get the ratings aren't that great in as far as H2S capture. It's just 5% compared to our sulfazorb, where is our sulfazorb? Here it is, our sulfazorb. Again, up to 70% by weight. So again, you can see here we come over to the dollar amounts. Cost per cubic foot. Yes, the regular activated carbon is more than the engineered carbon, our sulfazorb XL, but the cost to maintain it and cost per pound to H2S is a lot less. So you're going to get again a much larger capture rate with the engineered sulfazorb XL. That can equate to, say, less labor when it comes to having to change out the media because you don't have to do it as often. So those are some other things you really need to think about, when purchasing or coming up with what type of media you're going to use in your situation. But again, this goes over just talking about the potassium permanganates that I was talking about using for our polishing layer. Well, we use the sulfazorb for roughing. We're mainly going after the H2S. With permanganate and the blends, we're going after the other odors associated with wastewater. You can see that they're very excellent at the reduced sulfur compounds. Okay, and that's what we're putting them in there for. Again, a polishing layer of media. All right, now we're going to get into talking a little bit about the V-bank transition system, or known as the VTS. See some top view and a side view of a system. The systems have the highest airflow system to remove 95.5% of unwanted gases from the air. Again, you get a very large flow through these units, but then consistently still get that 99.5 and more capture efficiency that's needed and that's specified. Also, high efficiency horizontal airflow configurations made for spaces with limited height, but again, need that high airflow. For one reason or another, you don't want your neighbors to see these tall 20+ foot tanks, at your facility. And you need to handle some very high flows. That's kind of what they're talking about. This is great for certain situations as far as the footprint of this system. It's also the footprint, it's not as high as as a vertical system would be. So safety and the safety when it comes to working on this and changing out the media comes into play. And we'll talk about that here in a little bit. Constructions of material. FRP is standard municipal situations, stainless steel more so in industrial situations. Mist and grease, again, kind of briefly touch on this here and there, but the mist and grease eliminator is standard in municipal, but again, you're trying to get as much as the moisture, humidity out of the airflow to increase, and to the particulate matter to increase the longevity of the media. So again, very, very important. Then we're going to talk a little here about blow through versus draw through. We have a blow through system. I think next time I do this presentation, I'll have some actual examples of a blow through and a draw through. The blow through system, you're literally you're blowing the air, you're pulling the air from the odor source, and you're pulling it from the odor source and you're blowing it into the vessel. You're blowing it into the vessel. If you have, let's say, a gasket dairy or something along those lines that's failed, you're going to be blowing out air. Okay, so you're going to get odor breakthrough, which again, not a good thing when it comes to odor control. If you have a draw through unit, you're actually creating a vacuum through the vessel. So if you have that same air leak, it'll say, again, sample port, something like that. You're not blowing contaminated air out into the atmosphere. You're just actually pulling in or drawing a vacuum. So you don't have that odor breakthrough. And that's where a draw through is just seems to be a better concept. A lot of the times with an odor control system. And media banks, we'll talk about that a little more, but you've got different variations, very customizable. Got the half V, full V. If you're in between flows, or as far as the situation, as far as the footprint, you make the media beds a little longer than the standard, a little taller than our standard that you'll see in our engineering catalog. Again, to meet the customer's needs. This is actually a paper that was done for the Hyperion water reclamation plant out in California, done by some well-known individuals in the odor control business. This was actually a paper that it ended up being printed in the WEF, Water Environmental Technology magazine, done back in October of 2022. It's basically saying, we'll show a little chart here in a minute, but the best choice for the situation at the Hyperion wastewater plant was a V-bank system or a VTS or vertical flow, high flow VTS system. You just kind of see when you go right down to, here's all the different kind of technologies that were taken into consideration. Got a vertical flow single bed unit. Well, problem with this one is it's a low flow. You just can't get that much flow through, or not as much as needed at the Hyperion plant. A horizontal flow dual bed. Again, the functions were just not quite what they were looking for, or what was the best footprint or best fit for the Hyperion system. So we come down here to the V-bank or the VTS unit, which is the one that was chosen for this situation. And you can just see that there's, you check all the boxes here. Very high flow, compact, especially when it comes to the height. and the width of the system. Excellent as far as media life, moisture management, again, due to the slant in the vessel itself, and of course the mist and grease system. Ease of changing out the media. This is very, very important. Good access to it. Again, those kind of to go hand in hand as far as access, very simple. But if you go down here to some of the other technologies, it can handle the high flows that were candidates for this type of situation with very high flow. Got your radial flow, and you check out a lot of the boxes here. High flow, but okay, if it's real tall, you're 20 plus feet tall, whatever. You're not always good neighbors. You might not want that situation. We'll come back here to the media change out. Highly complex, because with the radial flow, the media bed is as long as the system is tall. So it's a lot harder to change out the media in a radial flow. But again, this paper, and again, they did a study of all the different systems, and this one checked all the boxes. This very high flow situation and footprint at the Hyperion plant. The benefits. Let's see, benefits as far as in airflow. Again, we've been talking about it already, but ability to reach, high airflows, standard units up to 42,000 CFM. Does not require air to, okay, so basically talking about the angle that it goes through the system. Well, a lot of the systems is taking almost a 90-degree angle from the blower to the inlet, then up through the media and up to the exhaust. With a gradual slope of the V, it's not as much of an angle. Vastly superior to radial flow and dual bed vertical beds, just like I just showed that on that chart. Kind of the reasons why. Okay, but those are usually your other candidates when it comes to very high flow wastewater odor control systems. That's the benefits again due to footprint. Okay. I know the mist and grease is basically built into the front of the system. Okay, so you don't have the mist and grease protruding out, so that's nice. It's basically these systems come on I'll call it an internal skid, so everything can really be put into place, and then you can just connect the incoming ductwork. It's very easy as far as the footprint of these, the installation. Again, the V-bank transition systems engineered for tight areas. Big cities, or we even have situations, that's why that's up there, is they bury these things underground so they're not seen. Out of sight, out of mind. No side access needed, which allows you to bring the units closer together, because you don't have to do any maintenance, or you don't need to get access to the sides of these systems. High efficiency horizontal airflow configurations for spaces with limited, again, talked about it already, limited height, which means very high airflow. Again, whether it be you're trying to be a good neighbor and you're not, you don't have people complaining about seeing these new big tanks down the street. That's one of the many reasons. Again, it's a footprint issue. Let's see here. Okay, so let's see. So benefits, broad range odor removal results. Okay, so yeah, very customizable. I've already talked about it a little bit earlier. But again, if you're in between flows, say again we can customize these systems by extending the length of the bed, extending the height of the bed. And that's what they're talking about here. Able to take out contaminants, not just one gas. Also, the beds, we have the ability to put two different types of medias in the bed. Okay, so again, like I was talking about earlier, what might have a roughing layer of media, which would be, like say, our sulfurs or high H2S capacity carbon, engineered carbons, and then on the next layer would be a polishing media to get rid of, again, the other gases that are associated with wastewater. That's what they're talking about there. And this is between what I was trying to say earlier, is between standard flow ranges. We can customize these systems to fit those flow ranges. Again, the high efficiency mist and grease. Again, something that should be, it is in our systems, very standard to protect the media, gives particulates and moisture, and just prolongs the longevity of. So again, better performance of the system. Better use of all carbon in the system. Again, very even flow through those V's, which allows for this. Maintenance. Again, this is a big advantage with the VTS units. Again, due to the height, due to the flat surface on the top of this vessel, very easy to get around on and to maintain. This actually is just talking about changing out the media, and it actually kind of goes through the steps of it. Shut down the media, shut down the system, connect vacuum truck to the quick connects at the base of each media bed. Which is very easy. Again, you don't even have to get up on top of the unit, and just connect to the base of the carbon bed or the media bed with the quick connects that goes to the vac truck. Vacuum until carbon no longer exists. Repeat for the other beds. And another nice thing about this system is that you can also, this one says any remaining carbon you go into the fill chute. So really you have two options when pulling the media out of, vacuum the media out of these systems. Fill media through the fill chutes. Again, getting up on this unit, it's a nice flat surface. You can see by the previous drawings of it. Close the lid. 2 weeks later, you're going to run the unit, let it settle. Any settling that occurs, add more media, and it really is as simple as that. Oh, here's some references. This is a gentleman out in Fullerton, California, a company, making comments about the ease of dealing with the VTS. I'll just kind of read it out. The VTS tanks are safer than dual beds when it comes to rebedding or changing out the media, due to the fact that you do not need to enter the tank. Again, when you need to enter a tank, say in a dual bed system, a vertical dual bed system, to change out the media, you're going into confined space, and then there's rules and regulations you got to abide by when you're doing the media change out. It is also easier, faster to vacuum the VTS tanks. Again, kind of what I was talking about, the quick connects at the bottom of each bed. And there's also a good safety measure to never enter the tank. Again, as far as, and it is true, and especially concerning confined spaces. Here we have many of the engineers that specify our systems. You can see them there: Stantec, Parsons, Hazen and Sawyer, CDM Smith, AECOM. Again, the list of some of the major engineering firms that do specify our VTS systems. Configurations talk about here's I think I mentioned earlier, we have what we call a half V and a full V. This one is for lower but still getting to your higher ranges of airflows. Again, we do have an industrial airflow range and a municipal airflow range. Kind of the difference is, in an industrial situation, we'll just use an H2S as an example. There's usually lower concentrations, so you can go up with higher feet per minute in those situations. With a municipal, you want to stay more in the 50 feet per minute. It's go up to 75, but 50 to 60 are usually more of the sweet spot. So that's, but again, it's just kind of showing the half V configuration, what it can do. And here's the full V for even higher flows, talking about the the missing grease and the way it's built into the system. This is, obviously your incoming flow. You have your blower, and again, it all sits as basically it does have its own frame. Where this unit can be picked up as a whole and placed and then ducted to. Again, this is just showing you what the full V looks like and what its flow capabilities are. You're showing the actual internals of the full V unit. Okay, you see here where you've got your plenums, you've got even plenums in the front and the back, and that allows for an even flow through these media beds. Of course, these are your media beds, and you can actually, these media beds have two sections, just like I was talking about earlier, where you can have two different types of media that can be changed at different times because they are divided by a screen, usually a poly screen and a frame. Again, this just shows you how the even flow and the way the flow goes through a full V unit. There's some examples of some VTS units. This one, actually, I know this one is in Arkansas. These are actually an example of some stainless steel, small, shorter, but still full V systems. Here are some units. I do believe that these units are out in California. You can see here's a side view, and you can just see that how you can, on this view here or this picture, you can see how they are somewhat close together again, because you don't need the side access to maintain anything on the sides of these systems. Nice looking piece of equipment there. Let's see here, V-Bank transition systems case studies. All right, here we have one. This is in Saudi Arabia. This actually is at an oil refinery, and they're actually using what we call a scavenger, a very high capacity by weight H2S media that they've taken advantage of in this situation. But they have very high flow, and they have actually multiple pieces of equipment. And you can see two of the ones that they have are some VTSs, or V-Bank transition systems. This is a system at RL Sutton Wastewater Treatment Plant, which happens to be in Cobb County, Georgia. And I don't know, this unit was put in, RL Sutton plant has a central sludge processing or sludge dewatering complex. People call them biosolids nowadays, but dewatering. They have a bunch of centrifuges in there, and they bring the sludge from all the other plants to this one main plant. Well, they needed some odor control for it. It's a large facility. So again, the VTS, very large flows, just makes a lot of sense instead of having multiple systems with, a lot of interconnecting ductwork, multiple blowers. You can do it all with one VTS system. And again, that's in a nutshell is kind of what's going on there at RL Sutton. Here's an undisclosed customer, very high flows, 120,000 total CFM. The main reason this is a manufacturer, and it's their primary odor control for their sites, and they are very reliant on full H2S removal for fabrication or manufacturing a product at this manufacturing facility. So again, very important to pull all the H2S out of, again, some very large facility. This is a case study at Robert O. Pickard Environmental Center, also known as ROPEC. But again, you can just see that it's a good looking application. They've got, a total of 15,000 CFM system, each one at 7,500. They do have our Solvazorb XL for H2S removal, CBS blend for the polishing layer, some ammonia Zorb, and Omnizorb, again, to get rid of some of the other odors associated with this wastewater treatment plant. And you can see that the efficiencies down here, pointer, Been using my pointer the whole time, guys. I'm sorry. You see 99.9% of the H2S and removal of 99.7% of the ammonia, which are the two main odors or gases they're having issues with. Yeah, this is just another view. So we have a common stack for all three units. Just again, nice looking, low profile system. And here's just some reporting on the efficiencies of the removal. This one I think is the ammonia concentrations. Yeah, and you can see they're getting 99 plus for all the removal. And then some of the other, methyl sulfide, hydrogen sulfide, methylcaptans. Again, you can see very high capture efficiencies or removal efficiencies in the tests, which is a very good thing. Let's see why PureAir design is superior. Again, the special design features of PureAir. And we've already been talking about a lot of this, but specific medias for needed applications. Many choices when it comes to medias to deal with the types of gases or odors that are in a particular situation. The vacuum ports we talked about for the ease of the media removal. I-beam supports for strength, and again, very strong. I-beam's a lot stronger, and you can point them out here in a minute. Again, mist and grease, very important. Already talked about it a few times. Get the moisture and particulate out of the airflow. Proven track record, over 30 VTS installed, 10 more purchased in this year alone. And again, just kind of an overview here. High efficiency horizontal airflow configuration made for spaces with limited height but high airflows. It's the best thing about its footprint. Guys, that is it.